So we will have step 2. In step 2, we will have 4 approximations. Here we will have x0, here we will have y0, here we will have x0 plus h by 2, here also we will have x0 plus h by 2, and here we will have x0 plus h. Okay. Here we will have y0 plus k1 by 2, where k1 we calculate here. Here we will have y0 plus k2 by 2, k2 we will calculate here. And here we will have y0 plus k3, and k3 we will calculate here. And finally we will calculate k4. So what is the value of x0 and y0 here? This initial value will be this values now. So y will be 2.4921 and x will be 1.2. So y will be 2.4921 and x will be 1.2. Now we will again calculate. Our h is 0.2 and our f of x comma y is again x into y. So our k1 will be h into f of x0 comma y0. H is 0.2. When we put x0 and y0 here, we will get 1.2 into 2.4921. So this value, if we calculate, we get this value as 0.5981. So we will have x0 plus h by 2. x0 is 1.2 plus h by 2, 0.2 upon 2. If we calculate this value, we get this value as 1.3. Similarly, if we calculate this value, where k1 will be from here, so we get this value as 2.7912. Now we will calculate k2. k2 will be h into f of x0 plus h by 2 comma y0 plus k1 by 2. That is, we replace x and y in this function by 1.3 and 2.792. So we calculate this value, we will get this value as 0.7257. Similarly, we will calculate x0 plus h by 2, which will be 1.3. We calculate y0 plus k2 by 2, where k2 will be from here. So this value turns out to be 2.8550. Now we will calculate k3. k3 will be h into f of this term comma this term. So instead of x and y in this equation, we replace x by x0 plus h by 2, which is 1.3. So 1.3 into, we replace y by y0 plus k2 by 2, and y0 plus k2 by 2 is 2.8550. So here we have h into h is 0.2 into these two values. So this value turns out to be 0.7423. So now if you see, these values of k are approximately close to each other. So just to cross check whether you are going on the right track or not, just see the values of k. So these three are very close to each other. Then we calculate x0 plus h. x0 is 1.2, h is 0.2, so it will be 1.4. And we need to find the value of y at 1.4 only. So y0 plus k3 will be from here, and y0 is 2.4921. We will get this value as 3.2344. Now we calculate k4. k4 will be h into f of x0 plus h comma y0 plus k3. So we replace h, x and y by these values, and we get something like this. And if we calculate this value, we get this value as 0.9056. So we got the value of k1, we got the value of k2, we got the value of k3, and this is our k4. After this, we will calculate the entire k. So k will be 1 by 6 k1, k2, k3, k4 plus 2, 2. So if we substitute all the values of k from the second step, we will get this value as 0.7400. So this is our k. After finding k, we will calculate the value of y. Y is given by y0 plus k. y0 now is 2.4921. So 2.4921 plus 0.7400. If we calculate this value turns out to be 3.2321. So this is the value of y at x equal to, so the value of x is this 1.4. So 1.4. So this is our final solution. So we have found out the value of x value of y at 1.2 and x equal to 1.4. So this is how we solve the problem on Runga-Kutta method. More such problems we will see in our next video, so stay tuned for our future lectures.